Welcome to LabMiss.com in our lab video series on Cisco SD-WAN. This is Metha, your instructor for this video series. For a complete list of SD-WAN videos, you can visit our website under the routing switching section. There you can also sign up for our newsletters to receive the latest video updates. In this video, we will continue exploring the capabilities of centralized control policy, and this time we are going to look at how you can change your SD-WAN overlay topology from the default full mesh to other topology like the hub and spoke or something else that is completely arbitrary. For our lab setup, we have the three SD-WAN controllers situated in our simulated internet, the vManage, vBond, and vSmart, and these are their corresponding IP addresses. We have the total of 6 WAN edges located at 4 different sites. The first site is the site ID 1, which is our headquarters, and that's 2 ISR 4K. And then the other 3 sites are considered remote sites. Site 101 with 2 ISR 4K also. Site 102 with a single VHCloud BR2, and Site 103 with our VH1000, and the router name is BR3. We have a fully established SD-WAN overlay here across 2 transport, internet, and MPLS. Each of the sites we have Windows machine that we can use for connectivity testing. Windows 2012 is site number 1 with the IP 172.16.32.40. For the remote site, we have either Windows 10 or Windows 7, and these are their corresponding IP address and the local subnet. We learned from the last video that by default, a WAN edge device will try to build IPsec tunnel to any TLOG it learns from the vSmart. And this could be a large number, especially if you allow tunnel to cross transports. Not only that, this provides you with a very little added benefit when you have that many tunnels. It taxes the router resources and limit your deployment scalability. In fact, Cisco encourages you to shy away from the full mesh unless you have a small SD-WAN deployment. If you have hundreds or thousands of routers or sites, and the full mesh is your hard requirement, then you will need to consult Cisco and get them to help you to pick an appropriate hardware platform to ensure your scalability. A common alternative to full mesh topology is hub and spoke. Because each spoke routers only need to maintain few tunnels to the hub router, the spoke router can be a lower end platform. So overall, you will end up with less expensive solution that is highly scalable at a sacrifice of the added delay between the sites and the dependency of the hub device. Nevertheless, the hub and spoke is still a very viable option, so this is going to be our first scenario, which let me go to the next page of our diagram. Scenario 1, hub and spoke. Just looking at this diagram, we are going to turn our site ID 1, our headquarters, and designate it as our hub site, with router R1 and R2 at the site being the hub routers. Then the 3 remote sites that we have is going to be considered our spoke sites, and any communication between them or between the sites will have to go through the hub. So that will be the first topology that we will be configuring. Let me bring up the web interface to our vManage, and before we do anything, let's do a quick trace route between the remote sites and see what that looks like right now before we apply our configuration. Obviously, you can do the trace route on the router CLI, but I'm going to perform the trace route from the GUI just so I can show you what that looks like. I have selected the router BR3, and let's see, maybe I'll try the trace route to BR2. So this will be the remote site to remote site communication. Go to troubleshooting, and the trace route option is right there. The destination IP is the Windows PC located at site 102. This would be our VPN 10, which is a service VPN, and sourcing it, I guess, from the inside interface of the BR3 router. Should be good enough. And go ahead and click Start. Okay, based on the output here, it looks like from the trace route perspective, the destination is only 2 hops away. The first hop is the BR2 router, 172.17.2.1, and then that's the final destination, right? So the traffic actually goes directly right now because we have the default full meshed topology between the remote sites. Okay, now we are going to create a policy that would change our SD-WAN topology from full mesh to hub and spoke. I am going to start the policy config in a new tab. This is going to be part of the centralized policy when you make changes to the topology, right, that is accomplished as part of the centralized control policy. Add policy. We need to add some site lists. The first one is for the hub, which will be the site number 1. And then our spoke site. So site spoke 101 through 103 by the site ID. Then we need to create the VPN list. The way the topology works is it gets applied to the VPN, so you have that ability to have a different topology for your different service VPN. For us, our service VPN is VPN number 10. So we'll create a VPN 10 with the number 10. And then the last thing we need to create under the list here is the TLOG. Okay, I'm going to create a TLOG list that will contain all of the TLOGs on both of the HQ-R1 and R2 router. And I'll explain this later when we get to use it, why we need this. We'll call it TLOG HQ, which will represent all the TLOGs available at the headquarters site. TLOG IP that goes by the system IP of the router. For HQ-R1 is 011. If you remember, the TLOG by definition is made of 3 things: system IP, the color, and the encapsulation. The first one will be MPLS, and encapsulation is IPsec. Here you have an option to provide a TLOG route preference. And we talked about the TLOG route preference in the last video. It's just give you an ability to have a TLOG being preferred over the other TLOGs that you might have. So instead of having it load balancing, for example, you can have it grouped together and being used first until that TLOG route goes away, then fail over to the available one. Right? So we can say that we may want to prefer the MPLS over the internet when we do hub and spoke type of traffic. So we can assign a higher preference for that. Let's say 200. Add the TLOG. The next one, let me do the all MPLS for now. So HQ-R2. I don't have the diagram. Yep, right there. System IP, system IP. Again, MPLS, IPsec, 200, and then we'll do the internet. Public internet, assign preference 100. So be less preferred than MPLS. And the last one, which is, I guess I had one too many. There you go. I want to say 216.0.12. Public internet, IPsec, 100. Click save. List it right there. Do a quick sanity check. Looks correct. Okay, click next. Here in the topology, we saw this also in the last video when we were manipulating the OMP or TLOG routes. Right, we did mention that there's some out-the-box hub and spoke and mesh type topology that you can select from as opposed to a freestyle custom control, do whatever you want type deal. Here is an opportunity to use the hub and spoke option that's being provided, because that's what I want to do. So we select hub and spoke. Provide the name of the policy. We can call this topo for topology, hub, spoke, and VPN 10. This is where you select the VPN from the list. Only affect VPN 10. If you have more than one VPN and they all need to be in the hub and spoke topology, then your VPN list should contain all of those VPN number. Right, then we have two sections right here that you can assign sites as hub or spoke. Go ahead and click Add Hub Site. We said our hub site is site ID number 1, or in fact we have named it appropriately. On the site list, so select Site Hub, click Add, and then same thing for the spoke. We have the site list, Add. Okay. At the bottom, there's an option for hub preferences. If you click into that, you'll be presented with a little bit more option. By default, traffic will be load balanced to all of the hub TLOCs. As you can see right there, all hubs are equal. All spoke sites will connect to all the hub. Since we said that we were going to have the traffic prefer the MPLS before internet, let's go ahead and uncheck that. And we want to make sure that the hub TLOC is advertised. Right, and this is where you tie the TLOC list that we created earlier to the configuration right there, TLOC HQ. Go ahead and click Save Changes, and then save the hub and spoke policy. All right, go ahead, click Next. Skip this section because it's irrelevant. Provide the policy name, we'll call it LM Topo Hub Spoke. And the topology, we already have the topology name for our hub and spoke for VPN10. Before we save the policy, let's see what's going on underneath. All right, let's take a look at the CLI. All the way down to the bottom, we can see that the policy is apply outbound towards the site spoke. Okay, so if you look at this diagram, we've got the vSmart right here, and the policy is being applied as the routes is being advertised to the spoke only. All right, as you can see, site list spoke. Here's the other list that we have: site hub, site spoke, and then the TLOC HQ and the VPN. Okay, so let's scroll back up, look at the policy that's being applied. So what it's doing in order to achieve the hub and spoke topology is it matches the OMP route. Okay, if the route belongs to the hub site, then it basically does nothing. Okay, VPN10 actions just accept. In other words, if it's the route that's coming from the hub, then it will be advertised unmodified. Next, we have the route that's coming from the spoke or belonging to the spoke, VPN10 also. What the policy is doing is basically overriding the route TLOC. Okay, so you can see set TLOC list, TLOC HQ. Okay, so what that does basically, if, okay, let me go back. For example, the route from BR2 advertised to vSmart will basically satisfy this conditions right here. As it comes down to BR3, by default, the TLOC of that route will be the TLOC that belongs to BR2, but what the policy is doing is that it basically override the TLOC and replace it with the TLOC of HQ. So when the BR3 look up the next hop, which is the TLOC of that route, it would not send, or it wouldn't know that it needs to send to BR2 directly, but instead it will be sending it to the headquarter, right, based on the TLOC list right here. And that's how the system achieved the hub and spoke topology, just by replacing the route TLOCs from the spoke. All right, so hopefully that makes sense. And then the last one, it matches the TLOC route, and the only TLOC routes that will be advertised is the one that's coming from the hub. Okay, so the TLOC route that's being advertised to BR2, it's not going to come down to any other spoke site, right? Because the default action is reject. The only TLOC routes that all these routers of the spokes are going to learn is the one that's coming from the hub. And as you see in a second, when we look at the monitor section in the GUI, right? When a router does not have a TLOC route, it would not build an IPsec VPN. In this case, because the spoke only knows the TLOC routes of the hub, the only type of IPsec tunnel you're going to see is going to be between the hub and the spoke, which makes perfect sense because that should be the only path that the spoke-to-spoke traffic would take, because we can certainly do away with the sequence 30, I guessed, right? In that case, because we already replaced the T-lock of the spoke with the hub, spoke will always send the traffic to the hub anyway, and it would not send the traffic directly, so there's no point to have that tunnel. Even though without sequence 30, we will have the IPsec tunnel, but it will never get used. So what's the point of having that, right? It's just wasteful. And that's what basically the sequence 30 is accomplishing here, is forcing the spoke to only build the IPsec tunnel with the hub by filtering out the other spoke T-lock routes. All right. Let's go ahead and save the policy and activate it. Okay, that's fairly quick. Now if I go back to BR3, let's take a look at the routing table. OMP route, receive routes, filter based on 17 to 25 or /25 right there. Okay, you can see that we have 4 routes via the T-lock of the HQ. Okay, 11, 12, MPLS internet. With the MPLS having the preference. So I guess when we set the preference earlier, it was actually route preference. I might have said it was a T-lock preference, but it's actually a route preference. And you can see that only the 2 MPLS that has preference of 200s is chosen and install. Even though the prefix belongs to BR2, the next hop is not, because the system already has the policy that override that. Let's look at the T-lock routes. Receive T-locks. And here you can see that the only groups of T-locks that the router received is the one that come from headquarter, HQ, R1, and R2, and itself. Okay, there's no T-locks from 101 or 102. All right, the policy, we did see that it was setting the T-lock preference to 20, and that's what is being reflected right here, although it doesn't really do anything. In this case, let's take a look at how having less T-lock routes affect the tunnel. All right. You can see we are down to 4 tunnels right now, and those are the tunnels that goes to the HQ, R1, and R2. Right? So there's no longer the site-to-site, or actually I should say spoke-to-spoke direct tunnel anymore, even though the different options are being listed here, but the actual tunnels are not there. Okay, so what used to be this many tunnel, I guess in this case could be 20. Still a quick count. We basically came down to 4. Okay, by using the hub and spoke topology. Let's go back and rerun our flow simulation. To 2.10. Okay, and as you can see right there, the next hop are the R1 and the R2 over MPLS. Because we have the tunnel restrict flag set from the last video, it only used the local color MPLS. So the local and remote color basically matched. So when BR3 communicates to BR2 right now, it takes the MPLS, bounds off either the HQ-R1 or R2 in a load balance fashion. Okay, so let's go back and rerun the trace route. .10. There you go. We are expecting to see an extra hop that belongs to either HQ-R1 or R2 right there. 10019, which I believe is a T-lock extension right there of R1. You can look at the trace route as well. It goes to either 10019, which is the R1, or the 10012, which is the HQR2. Okay, so it clearly load balance to the hub first before it comes down to the BR2 router. All right, you can see before it was 2 hops and now there are 3 hops. What about if we change that to the subnet at site 101? Yep, same deal. It traverses the hop first. So 3 hops before it gets to either the BR11 or BR12. Let's test the failover real quick. I'm going to go ahead and shut down R2 MPLS. So this guy right here, that will cause the IPsec tunnel terminates on the MPLS on the headquarters to go down, and hopefully it will fail over to the internet. Okay, let me bring up. Looks like I still have that open for the previous lab. So HQR2 MPLS interface is gig 104 on the switch. I'm going to go ahead and shut that down. Give it a couple seconds for the failover to happen, and I'm going to rerun the trace route. It doesn't matter if I run it against site 1 or site 101 or site 102. We expect the 10.0 IP to change to the 1 dot something, which is our internet IP address. Okay, just FYI, our internet IP is right there. It should be a 1.1 or a 1.2, I believe, but the MPLS is a 10 dot something. So expect to see a 1 dot something here. There you go. So it looks like it goes through the 1.2 and it does load balance to a 1.1 as well. Okay, 1.2 is the IP on HQR2 as part of the TLOC extension, and then the 1112 is the IP right here, the internet. Okay, so the failover happened successfully. Yep, let's do a no shut and put our policy back to its original, which is nothing, so I have to deactivate it. And that's basically how you configure the hub and spoke topology. All right, so let's see what else we can do with this topology configuration. Let's go back to our scenario or diagram. Scenario number 2, mesh region. Here we assume that we have sites in 2 regions that need to stay isolated, but remains being meshed within the region, although it's not so much of a mesh because in each region I only have 2 sites. Okay, but imagine that you might have multiple sites, and within this region and this region, it will be a complete mesh. So we have the site 1 and 101 in what we call a region number 1, right there. So site 1 and site 2, and then we have the site 102 and 103 in the region number 2. So let's see how we can accomplish this. First, we need to create site list. Let's add a new policy. On the site, we'll call it site region 1, 1 and 101. And then site region 2, 102 and 103. Then we get to the topology. But instead of hub and spoke, we are going to select mesh. And we'll call it topo region mesh VPN 10. Apply to VPN 10, just like before. And here you can pretty much create as many mesh region as you want. We only have 2. So the first one will be called region number 1. With the site list of site region 1, and then region number 2, site list region 2. Save that. Skip forward to the policy name We'll call it LM Topo Match Region. And then we don't have to specify the site or anything. It's already done as part of the topology configuration earlier. At this point, it should be all set, but let's take a look again what the CLI looks like. All right, so the policy is still being applied outbound, but we do have now two different policy being applied to two different groups of site. Okay, so we still have the vSmart, right? The first policy is applied to region 1, and then the second policy is applied to region 2. Outbound. This is the list that we created, VPN number. Let's review the two policies that we have. The first one assumes for region 1, so any routes that's originated from the site in region 1, we're going to pass it right through. Okay, so it acts as the route filter, basically. What it means is, if the route is being advertised from, say, region 2 over here, it would not be advertised or relayed to the sites in region 1. So that's not going to happen. Okay, just the route within their own region. That means the sites in region 1 will not know about the routes that's coming from region 2. And the same thing for the T-lock. So it's all self-contained within the site. Having the T-lock routes being filtered this way also means that there would not be any IPsec tunnel being created between the region. And if you look at the other policy, it does exactly the same thing, but using the site list for region 2. So technically, we're not really manipulating routes or anything here. We just do route filtering, if you think about it. Go ahead, save policy, and activate. To validate this, we can go to HQR1. Let's take a look at the region 1 first. Real time, look at the OMP routes, receive routes, and we only expect to see the route that belongs to site 101. Okay, just look at the, let's see, the originator. There's that right there. All right, so these are the local routes, and then the only other system IPs that we're seeing here belongs to the BR11 and BR12 routers. Nothing 101, or I'm sorry, nothing 102 or 103 here. Okay, just the 101 and 111. What about T-lock routes? Same deal. We only see the T-lock that's coming from the site 101. And not 102 or 103. What about the tunnel? Okay, so we see the tunnel goes to BR11 and BR12 for the MPLS and internet. Okay, nothing again going to the BR2 or BR3. All right, so from the Windows 2012 over here, actually this diagram, we should be able to ping the Windows machine in 101, but not the 102 and the 103. So let me bring up the ping from the headquarter to site 101, 1.10. Okay, no problem. But we can't ping 2.10 or a 3.10. Okay. Then let's switch this to BR3. And BR3 should only receive the route from the BR2. So let's look at the receive routes. No filter. Looking for the originator. As you can see, it's only 102 and 103 here. 103 being the local routes and 102 being the route learns from 102. Okay, there's no 101, 111, 11, or 12. Should be the same for the T-log. Okay, only the 102 being learned. The tunnel should only goes between the 102 and 103, which is BR3 to BR2. Okay, so we're down just 2 tunnel, one over MPLS, the other one's over internet. And this time we can do a flow simulation from 310 to 210. Yep, it would load balance between internet and MPLS. But if you're trying to go to 1.10, which is in a different region, you can see we're not getting any path back. Okay, so BR3 kind of just talk to BR1 like that. All right, so that's basically accomplishes what we want to do in terms of the scenario number 2 mesh region. All right, now that you have kind of gotten the feel of how to override the route T-log to change our overlay topology, let's take on the full configuration upon ourselves to achieve the topology in the next scenario, which is our scenario number 3. We call it arbitrary. Say that you primarily still want the hub and spoke for all sites, but there are certain sites that you want to allow direct communication. All right, this could be, for example, the traffic that goes between the data center sites or any major regional sites. Here assumes that the headquarters is a regional hub, and then the site 1 and 2 are the data center that require direct connection, and the site 103 is just a typical spoke branch. So this is basically the same topology as what we had in scenario number 1, except that we want a direct site-to-site communication between 101 and 102. Now let's think about how we are going to achieve this. So the headquarters will still have the direct access to all other sites, so there isn't really anything that we need to do as far as the route that's being learned from vSmart. So this should just be everything accepted, unchanged. So basically we don't need to apply a policy to site number 1. Now for site 101 and 102, they needs to learn each other's routes via the original T-logs, while any other routes, for example, for the 103, it needs to be pointed to the headquarters. All right, so it basically needs the 2 topology config, one for the 101, 102, and the other is for the 103. Okay, because 101, 102 is the exception. Now let's create the policy here. Add new policy. Create some site list. We'll call it site DC for 101, 102, and site branch for the 103. Next, we create the topology. We want the custom this time. Okay, we'll call it Topo DC VPN 10. So this policy will be applied right there for the sites that's considered the data center that needs direct communication. At the sequence type, the first one is the OMP route. Add the rule. We're simply going to match based on site. So any route that's originated from the data center site, all we need to do is accept. Now maybe I'll throw an attack in there too, so we know. Okay, so I'll tag it with the site ID 101, 102. All right, so that will take care of the routes that belong to those two sites. Those two sites do need to learn routes from other sites, but we want it to point to the hub. That's pretty simple. You don't basically need to match anything. Okay, all you need to do is making sure that you accept it and you overwrite the T-lock using the same trick that we've learned from the hub and spoke. Select T-lock, and we already have the T-lock list going through the headquarter. And also tag it with tag 1. Okay, representing the site ID of the headquarter. But that's only for allowing the OMP routes, right? We're still not allowing the T-lock route. If you just leave it like this, then there would not be any tunnel being created because these sites would not be learning any T-lock routes. So still need to make one more sequence type for the T-lock routes. And let's think about who needs to talk to who. Okay, so the data center needs to build the tunnel to each other. And then it also needs to build the tunnel to the data center. But that's it. It would not be building tunnel to the other branch spoke. In this case, we need to match it by site. Right? We need to allow the hub. And then we also need to allow the DC sites. And that's it. Okay, so this is site 1, this is site 101, 102. Go ahead and click Save. We need one more policy. Okay, I don't like when it doesn't show like that. Hopefully we don't lose the config. Actually, we might. You know what? It might be saved already, so let me try to import and see if it's there. Yep, there you go. It did get saved. Just need to import it. All right, I need to create one more for the spoke. Okay, so we need a policy that gets applied right there, outbound, from a vSmart. We'll call it topo BR VPN10. And this one should be super simple. Any route that's being advertised to the spoke, its T-lock should be pointing to the headquarter. So type route. We can just set accept T-lock HQ, and maybe we'll tag it with number 1. Okay, so any routes will get the T-lock replaced by the HQ T-locks, and don't forget, nope, that's not right. We want the T-lock routes. The BR3 only needs to build tunnel to the headquarter. Okay, it doesn't need to build tunnel to 101 or 102. That means that the only site T-lock that we need to advertise is the one from the hub. Okay, action accept. Save, and that's it. Click next. Give the policy name lm topo arbitrary. Okay, for the BR1, it's going to be outbound to, okay, I don't see the whole option. There you go. Site BR. And then for the topo DC VPN10, it's also going to be outbound to the DC site. Okay, click add. Again, make sure these site lists do not overlap, which they don't. This contains 103, that contains 101, 102. We can preview the config. 2 separate site application, 2 separate policy. First one for DC, anything that originated from the data center will just be passed right through with the tag. And anything that's originated elsewhere will have the T-lock being replaced by T-lock HQ and tag 1. T-lock route is going to be learned from the hub as well as the DC. No spoke. And then the VPN 10 for the BR. I guess I could also match by the VPN, right, since I call it VPN 10, but it's okay because that's the only VPN that we have anyway. Otherwise, I could just do match VPN here as well. Basically match any routes. All the routes that's going to be learned by the branch spoke will be having the TLOC next top of the HQ. And it's only going to build the tunnel to the hub site. Go ahead, save, and activate. Arbitrary, activate. All right, now let's begin by looking at maybe BR2. So BR2 is part of the DC to DC. Real time, look at the OMP route being learned. Let's do no filter for now. Okay, let's look at the TLOC. You can see the majority of the TLOC shows up as either 11 or 12, and that's HQ, R1, or R2. Okay, there's some 101, but we do not see anything 103. The routes are also tagged. Let's see if there's a tag here. Yep. So based on the tag, you can tell already. If it's tag 1, we know that it's anything else. But if it's a 101, 102, that's the DC to DC routes. Okay, so those are most likely came from the 101 or the... I was looking for 111. Oh, I see why. I didn't pick BR2. My bad. I thought I did BR2. I did BR12. So BR2, there you go. Let's take a look again. Yep, so 101 right there. Yeah, there you go, 111. Okay, 101, 111. Everything else is 1. Yep, and we can filter the prefix. It belongs to site 101. And you can see the tags are all there. Originator that we saw earlier. Let's take a look at the received TLOC next. It generally learns about the BR11, BR12, and the HQ, okay, based on the IP. HQR1, HQR2, BR11, BR12. Actually, this one right here is local. There's nothing 103. All right, same deal. That gets translated to the tunnel. So there's no tunnel to BR3, only the HQ and BR1, both MPLS and internet. So that's working as expected. Let's do a trace route. This would be from BR2. Let's go to BR3, which is 3.10. So this one, it should go through headquarter. Okay. Yep, and it does. 10.0.1.2 with MPLS being preferred. Okay, 3 hops. But if it changes to 1.10, you can see just 2 hops away because it has direct connection. All right, so from BR2 perspective, that's working correctly as designed. Next, we're going to look at BR3. Okay, change it to BR3. Receive routes. OMP. We expect to only see the headquarter TLOC here. Look at the TLOC. Yep, it's going to be either 11 or 12, except the local routes, obviously. but otherwise everything is pretty much 11 or 12, right? Because all the routes has been replaced by the HQ T-locks. Look at the OMP T-lock received. And there again, it only learns the T-lock from HQ. There's nothing 101, 111, or 102. That means it should only have the tunnel built to headquarter. Right, HQR1, HQR2, that's it. And to do the trace route, doesn't matter if it goes to Site 101. You should go through the headquarter right here. And same deal going to the Site 102, it goes through the headquarter right here. Okay, so we have validated our scenario 3 topology. Let me go back and deactivate. In our last scenario, scenario number 4, we are going to try some other matching attributes that we have not yet used. Here we have some outbound. I guess we have selected the headquarter to advertise some routes to vSmart, and in the outbound, this is what we're going to do. For this particular prefix, 172.16.0.10/32, which I believe is a switch 1 loopback 0, we're going to tag it with OMP tag of 1. And then we're going to deny the OSPF originated routes. And finally, we're going to deny any routes that's being originated from R1, R2. So let's start with that before we do the outbound, and we can validate as we go. Okay, so first we need to create a prefix list for switch 1. And by the way, this is not so much of changing the topology, but I just want you to see a variety of the matching condition. Actually, the policy, go to the prefix. By the way, the difference between the prefix and data prefix is that this prefix right here is for the route prefix, as opposed to, well, when you deal with the control policy, as opposed to the data prefix, is when you configure, for example, ACL when you deal with the data policy. So in this case, we're still using this prefix right here. We'll call it PFX HQ switch 1 loopback 0 172.16.0.10/32. Great, click add. Next, topology, custom, we'll call it topo custom, and the inbound direction, because we're going to apply that inbound to vSmart. We're going to do route. First, we're going to match by prefix list of that switch 1 loopback. Actually, that's not, that might be the same one, but that's not what we created. Yep, this one right here. HQ switch 1 loopback. Action will be accept, and we're going to tag it with the value 1. Although we did see some tagging in the previous scenario as well. All right, so let's try that first, just that. Oh, looks like I missed. Again, this is something that you might forget. The default action, right? If I left it out, then the only route that our site's going to learn is that switch 1 loopback. So we need to change this to accept. Save. All right, it's doing that again. So I need to refresh and do the import from the custom in right there, we just created. Okay, then click next. Skip that, provide the policy name, LM topo custom. And we're going to apply that inbound to the hub site. Okay, so it'll be as it being advertised to vSmart. Click Add. Preview, pretty straightforward, match by prefix list. Set the tag, and that's it from the hub site. And then we have to activate custom, activate. Okay, to validate, I'm going to hop on to BR3 still. Look at the OMP receive route. Is it done yet? Yep. The only route that we should be seeing getting the tag of 1 is that switch 1 loopback. Okay, receive routes. See if I can just locate it based on the tag. Okay, did I activate the right one? Because there's a lot more tagging than we expect. Yep, I did activate the custom, right? We're certainly getting more tagging than we hoped for here. Okay, let me go back and check the policy real quick. And this will be the topology, custom in, edit, prefix SQ switch 1 loopback. I have the feeling this might be just cosmetic because we ran into this in the past, so it could be that it's not supposed to be shown up as tag 1. So what I'm going to do instead is to go to the CLI and look that up on the BR3. If I do show a OMP route, I don't think I need a detail option. And fast forward to 0.10/32. You can see the tag 1's right here. All right, and then when we look at 0.11, we do not see the tag set there, even though on the GUI it said so. Okay, and that is 0.11/32. So that's obviously a cosmetic bug on the GUI. So we're not going to concern ourselves with that. All right, then what I want to show you is this guy, the protocol origin protocol OSPF external 2. So we have a bunch of route that's coming from OSPF on the back of the router, being learned as OSPF type 2 or external 2. Then our next rule is going to be denying OSPF originated routes, right? Which is these routes right here. So when we're done, those routes should go away. Except for, I believe, let me see if loopback. Yep, that one is also OSPF originated, but because we already have a rule that except that should not be affected. All right, come back here. We're still under the topo custom in. We're going to add one more rule. And this time we are trying to use the matching condition of origin, specifically for OSPF external 2. All right, we're going to leave that as reject. Great, click save and activate. Let me refresh this. Yep, as expected, the majority of the OSPF external 2s are gone now. As you can see, scroll all the way down, they're all left as connected. And the only route that remains with the OSPF external 2 is the switch 1 loopback 0, because we have the rule that matched it right here, so that gets exempt. and then everything else that doesn't get matched by rule number 1 will be denied by rule number 2 as far as OSPF external. So that seems to work correctly as well. Now let's look at the remaining routes. Alright, so for the most part, the route that's still coming from the headquarters, as you can tell by the T-locks right here, is just a loop back of R1 right here and R2. The last rule calls for deny any other routes originated from HQ R1 and R2. And that's just to show you that you can also match it based on the originator of the routes. So we're trying to match by prefix, match by the origin protocol, and the other condition I'm going to show you is the originator. All right, and that's just based on the system IP address. So for the HQ R1 is 16.0.11. Yep, as you can see right there, and then the 12 for the R2. I'm just going to deny that. Yep, one more. We can't put that in the same rule because it's an AND, not an OR. So for an OR, it has to be a different rule. 12. Activate. That should get rid of any other HQ originated routes. Refresh. As you can see, 0.11 and 0.12 is no longer there. So the only routes we're left with being advertised by the HQ is the switch 1 loopback 0 that we explicitly permitted. Now let's take a look at the outbound rules that we have here that we're going to configure specifically for BR3. We are going to deny the route based on a matching of attack number 1. And if you remember, the only route that remains from headquarters that's TAC 1 is switch 1 loopback 0, so we're going to get rid of that. And then we're going to play around with some traffic redirection. We're going to reroute traffic from BR3 that usually goes directly to BR1 and have it routed through BR2. All right, so it's going to go like this. Let's try the first one first, which is denying the route with TAC 1. What I have to do is to create a new site list. So we can apply the policy 2 for the site 103. Just going to call it site 103, and that will be 103. Then create a new topology, custom, call topo custom out, and we're going to match it based on tag, OMP tag number 1. Action should be the default reject. All right, and the default, let's make that accept. Actually, let me show you. Edit the preview of the CLI, pretty straightforward. Nope, did I not configure that or save it properly? Okay, all right. Sometimes I forget to add the rule and it doesn't stick. We'll do it again. There, action, reject. There you go, save it. Now look at the preview. Very simple, match OMP tag of 1 and then deny that. Everything else would be allow. You have to go back to the policy, and which is the custom. Jump to topology and then import the policy we just created. Right, because we create outside the whole wizard that we did. So we're going to do the import. Okay, it's not doing that. Then I need to refresh the browser. Try again. That will be custom out. To apply that, go back to the first tab, custom out, select the site. We say it's going to be apply right here, outbound to 103. Yep, so we need to select 103. And add. Okay, we can preview that, custom out, and that would be applied to 103. All right, go ahead and activate. What we expect is this route right here that's being tagged as OMP1. So this would be interesting to see because it claims that the other route is also tagged as 1. Because we already concluded that these are cosmetic bugs, it should only affect the first route. Yep, done. Let me refresh. And yep, the 0.10 is no longer there. And it took away the OMP tag for the other routes with it. Okay, so clearly there was the issue with the GUI. So that works fine. It's completed that. Now we are going to reroute traffic from BR3 that goes to BR1 through BR2. Okay, it'll be the same concept as the hub and spoke. We're basically going to replace the route that 103 is going to learn that belongs to 102, or actually belongs to 101, and then replace it with the T-lock of 102. So that way it sees 102 as the next hop to get to 101. Go back, we need to create a list of site for site 101. Okay, we'll call it site 101. Click add, and then we need to create a T-lock list. Just like how we did with the T-lock HQ, we'll call it T-lock BR2. And that would be 16.0.102, the system IP of BR2. We've got MPLS, IPsec. We're not going to mess around with the preference, so it's just going to be equally load balance. Public internet, IPsec, and save. Now we need to go back to the topology, custom out, and we're going to add another rule, right, that will match the route that belongs to site 101, and then we're going to accept and replace T-lock with BR2, just like that. Save. I guess we can preview it real quick. There you go, match the route from site 101, replace it with the T-lock of BR2. Guess we can look at the before output. That will be 172.17 right there, 2.0. Right now, the T-lock belongs to clearly, or actually no, we're looking at right there, the 1.0. That belongs to 0.101. That should change to 102. Okay, these 4 lines right here, because we're replacing the T-lock. Should be done, I assume, so let me refresh and look right now. There's 4 lines. Yep, doesn't look like it's working. Oh, I haven't applied it. I thought it was it. When I click activate, there's a couple more clicks that I have to do. Okay, done. Try again. Yep, so 4 lines collapse down to 2. Because there's only 2 T-lock at 102. Okay, the MPLS and internet. So now if we do a trace route as a last step of validation from BR2, actually BR3 is correct, going to BR1, 1.10, start, which you see the BR2 be inserted in the middle, right there. Let's say 217 2.1, that belongs to BR2 inside interface. Right before it keeps going to BR1 and the final destination. As a quick note that BR2 knows to send the traffic to BR1 when it receives that traffic from BR3 because we didn't manipulate how the BR2 sees BR1 routes. Okay, so it forward the traffic to BR1 correctly. Right, we only did that on BR3. Just know that the return traffic from BR1 goes still directly to BR3. All right, I think that's all I want to go through in this lab. Before we finish, let me deactivate the policy. Hopefully you've seen enough of different ways to control your SD-WAN topology. Just keep in mind that this is just a subset of what you can do. So far, we have used the attributes like site, VPN, prefix, tag, the origin, originator, and things like that. In the future lab, we will see that we can get all the way down to port protocols and even the application using the data policy as opposed to the control policy, right? As well as the application aware routing. So be sure to check out those videos as well. One last thing to note is the way that we have multiple policies set up allows us to easily switch between the topology, right? As we saw earlier on the topology page. Here we have 4 different kind of topology going on, right? And these can potentially affect the entire SD-WAN, which is a very powerful feature of Cisco SD-WAN, right? And it's something that cannot be achieved in the traditional WAN configuration or methodology. Okay, just by simply activate a certain topology or the policy right here, I will be able to switch from hub and spoke to some mesh region, right? To some arbitrary or some weird custom configuration. And that wraps up our video on SD-WAN topology. You can visit our website to view an extensive list of our lab videos and sign up to get access to additional lab contents. Thank you for watching labminutes.com, and I'll see you guys in the next video.